Okay, this is lesson 10, applications of volume. For each figure, there's two real world items that represent this figure. Okay, since I'm doing this on my own, I'm just going to tell you what the two I have. Okay, again, I'm going to try and refocus this. There we go. Okay, so for a cylinder, I picked a can, and I also picked a science beaker. Okay. For the cone, I picked an ice cream cone. And I also picked a traffic cone. You could be picking other things, okay? I picked a basketball for a sphere. And I picked a globe. Okay. So for here, other responses could be together. It just depends. You can put your heads together and figure something else out. Okay. But that's what we are going to work with. Okay. So now let's look at some problems that we have. Okay. The first one we have here is Tanya uses cubed shaped beads to make jewelry. Each bead has a cylinder hole through the middle right here. Find the volume of each bead, round to the nearest tenth. So what we need to do is take the volume of the rectangular prism, okay, and then we have to take the volume of the cylinder, okay. So that's the first thing that we need to do is take the volume of each of these, okay. So the volume of the rectangular prism is our volume equals pi r squared h. So here we've got, sorry, oh God, already I'm starting here today. Seventh period, guys, and just trying to get through this. Length times width times height. So we've got length times width, and our height, because it is a rectangular prism, it's a square, so it's 12 times 12 times 12. So 12 times 12 times 12, that all equals 1,728, and that is millimeters cubed. The other way that you can multiply this, guys, with your calculators is 12 cubed, because it's all multiplied to itself, so 1,728. For the cylinder, that's the formula I wanted, which is pi r squared h. Duh, for me. So we have pi, our radius, because this right here, they're telling us the diameter is 2, okay? So the radius is 1 squared. Our height is 12. So now we have pi, and because 1 squared is 1, okay, I am going to put that 1 in just, for us. So the 12 times pi, okay, so you have 12 times pi is 37.6991184. Now, because of this, okay, what we're doing is this is a whole, which means we need to subtract that out. So we are going to take the 728 and subtract the 37.6991184, because when it's rounding, you do that at the very, very end. Okay, so when we subtract these two numbers, I get 1690.300888. So rounding to the nearest tenth, my volume equals 1690.3 millimeters cubed. Okay. Our next question is a metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5 inches, a diameter of 2 inches. How much does the paperweight weigh if 1 cubic inch weighs 1.8 ounces? Round to the nearest tenth. Okay. So now with this one, here's what we need to do. Okay. Here we have the first thing we need to do. Okay. We have a height of 1.5 inches. We have a diameter of 2 inches. Okay. Which means we have a radius of 1 inch. Okay. So now we have a volume, okay, which is pi r squared h, because it's the shape of a cylinder. Okay. So now when we find that, okay, we have pi r squared. I got to replace that because we already have the formula there. Sorry. So the radius is 1, so 1 squared. Our height is 1.5. So pi times 1 times 1.5. So our answer here is 4.7, 1, 2, 3, 8, 8, 9, 8. Okay. Now we need that, okay, because we need to know how much does the paperweight weigh, okay, how much it weighs. So in order to find that, okay, we need to take this amount, okay, so we need to find the weight. So the weight of that, okay, would be 4.7, 1, 2, 3, 8, 8, 9, 8. And we're going to multiply that, okay, by 1.8 ounces. Okay, we're going to multiply that by 1.8 ounces. Okay. So multiplying that, okay, we get 8.48, 230, 0.165. And we need to round that to the nearest tenth, which would be 8.5 ounces. Okay. Because if it is 1 cubic inch, okay, so for every cubic inch, okay, because this is inches cubed, okay, that's how much it holds. That's the volume, okay. So it has 4 cubic inches, okay, and we're multiplying that by 1.8 ounces, okay. That's how you're getting that, okay. So our next question. Question number 3. Okay. An above-ground swimming pool in the shape of a cylinder has a diameter of 18 feet. Okay, so your diameter is 18 feet. And a height of 4.5 feet. If the pool is filled with water to 6 inches from the top of the pool, what is the volume to the nearest cubic foot? So we have to find the volume to the nearest cubic foot, okay, of the water in the pool, okay? So first of all, our diameter is 18 feet, which means our radius is 9, okay? We also know that our height, okay, our height is, we're going to use 4 feet for right now, okay? And this is because we have the 6 inches from the top of the pool, Okay. So if I take that 6 inches, okay, that is half a foot. Okay, that's half a foot. So I need to take that 4.5 feet and subtract 0.5. So we are actually only filling it to 4 feet. That is how I'm getting the height of 4 feet. Okay, so now when I do my volume, I'm getting pi r squared h, because it is in the shape again of a cylinder. So we have pi r, radius is 9 squared, times 4. So here pi 81 times 4. And again, we need the big old long number simply for the fact is we need to round it to the nearest cubic foot. So we have 1017.87 602. Rounding this to the nearest foot, we have 1018 feet cubed. Okay. I believe our last problem, yep. And let me move this up, is a cylinder that and a cone have the same volume. Okay. The cylinder has a radius of 2 inches and a height of 3 inches. The cone has a radius of 3 inches. What is the height of the cone? Well, what we have here, if they have the same volume, that means the cylinder and the cone are the same. Okay, they're both the same. Okay, and we need the height of the cone, which means we need to find h. Okay, we need to find h. So the cylinder, which is this, has a radius of 2 inches. And it has a height of 3 inches. The cone has a radius of 3 inches. And again, we need to find the height. So now we're going to multiply this out. We've got pi, 4 times 3, 4 times 3 equals 1/3. Pi times 9 times the height. Here I can start to cancel some things out. 3 goes into 9 3 times. So I have 3 pi times the height. Here I've got 12 pi. Now I can divide the pi's, ladies and gentlemen. I'm allowed to do that because they are variables as well as numbers. They're numbers that can be divided. So I can divide both sides by pi. Those are gone. So I have 3h equals 12. Now I can divide both sides by 3. So my height is 4. So the height of my cone is 4 inches. And that is our lesson for today.